So now we've looked at how important electrochemistry is to the global endeavor because of the fact that it has the capability of eliminating fossil fuel combustion entirely. And we've also looked at how electrochemistry unifies all of the ideas that we've worked on up to this point. So the next aspect we want to look at is, as we go into the basic ideas that constitute modern electrochemistry, what are the most important aspects that this brings out? And we can't help but begin by pointing out that when we look at chemical potential, and we represent that by delta G, and we have just reviewed from whence delta G emerges, namely the second law of thermodynamics, and we can create an electrochemical cell that uses the release of Gibbs free energy between reactants and products, and we're going to see how that's done. And what's remarkable is that we've looked at oxidation reduction at this point, but we've represented it as a delocalization of electron density within a molecular structure. Now we want to relate delta G to an arrangement that allows electrons to flow through an external circuit. That means that we can transfer electrons from one coast of a country to another coast of a country. We can transmit electrons over thousands of miles if we can figure out how to separate the point of oxidation from the point of reduction. So we can do that, and Michael Faraday was the genius behind developing this technique, but it meant that we can create an electrochemical cell that produces voltage. That is, we can relate the chemical potential to the electrical potential in terms of the voltage produced by that chemical reaction. But the minute we produced a voltage and we deliver that to an electric motor, we can do work. We can raise a mass through a gravitational field and do an amount of work equal to mg times the change in height of that mass by virtue of converting that voltage through an electric motor to do mechanical work. And that means that we've related chemical potential to electrical potential back to gravitational potential, which is mg delta H. And that's a remarkable connection that electrochemistry delivers to us. Now, the other thing that electrochemistry does for us, and this is extremely important for the development of energy for people who do not live close to an electrical grid. In the developed countries, these electrical grids are everywhere, but not so in many, many countries. And it's also true that by delivering various forms of energy to the population off the grid, we can learn a great deal about the chemistry of how these processes work. And one example is the conversion of light to a chemical fuel. And as we'll see when we study quantum mechanics, we can work out the development of materials which, when illuminated with sunlight, produce a voltage. And as soon as the voltage is produced, we can use that in many different ways. We can use it to light light bulbs directly. We can use it to drive automobiles directly, but we can also use it to produce fuels. And this is a process called electrolysis, and we'll see that electrochemistry is a very crucial part of this development. And so when we look at the chemistry behind this, we realize that when we produce that voltage, we can extract electrons from one electrode, and we can flow electrons into another electrode. And this is oxidation, and this is reduction. And we're going to see when we develop electrochemistry exactly how this works, but it has huge implications for bringing energy of all sorts to people off the grid globally. And for example, the production of hydrogen by this process, which evolves from breaking water apart to produce hydrogen and oxygen, and to balance this, we're going to need two water molecules producing 2 hydrogen molecules and an oxygen molecule. And the hydrogen that comes off of this reaction can be used as a fuel. It can be used as a fuel to cook. It can be used as a fuel to light light bulbs. It can drive fuel cells, which we will study, and it becomes an extremely flexible and important process for generating energy. So let's just remind ourselves very quickly about what the transition to an electrochemical economy looks like. We transition from a system that is driven by fossil fuels to a system that's driven by the generation of energy through renewables, particularly wind, solar, high temperature geothermal. All sorts of these are available to us, and that moves us from an era where heat engines dominate to an era where heat pumps dominate and electric cars dominate. And that's the objective, and that is the bridge that electrochemistry provides for all of us.